thank you. Right, am I doing number one? Anyone need me to do number one? Was there yeah? No? Right, number two. We're okay with number two? Number three, I said just get the volume. Number three, just get the volume. Or you couldn't get the volume because I see what's wrong. Okay, right, do my number three. I'll get to it in a minute. Number four, will I do it, yeah? Right, okay, so number four says the volume, so they're giving me the answers. So they're telling me the volume is 360 pi. So that means the volume is 1/3 pi r squared h is the formula for a cone equals 360 pi. What I do now, there's a pi at each side, knock off the pi's, right? And then fill in what you can. So this is 1/3 multiplied by the radius squared. They didn't tell me what the radius is, but they did tell me that the height was 30. So I'm filling in that. Okay, equals 360. Okay, multiply the numbers you have. So on your calculator, do 1/3 multiplied by 30, right, which would be 10r squared, right, will give you 360. Divide by 10, so that means r squared is 360 divided by 10. That means r squared is equal to 36. So what number squared will give you 36? 6. And put a unit on it, everything was in centimeters. Okay, is that right? Yes? Right? Yeah? You divided it by 30.
Yeah. Yeah, I divided 360 by 30.
Right? And you got...
I got 1.
Yeah, you left out the third. There's a third in this formula.
Yeah, no,
So what did you do with it?
yeah, so I had 1 squared multiplied by 1 squared multiplied by 30 is equal to 360.
Yeah?
And r squared is equal to 360 over 30.
Yeah, so you've just dropped the third. Where did the third go? Do you know what I mean? It's 1/3 multiplied by r squared by 30 equals 360. Okay, if you want to isolate r squared at that moment in time, you're dividing by 1/3 multiplied by 30. Okay, you just kind of drop the third. Okay, so the best thing to do is multiply the numbers you have. Okay, right, are we okay with that? Right, okay, so I need to go back and talk some more about the cone. I had just given you the formula yesterday and I gave you homework on it, but we really didn't talk about it. Right, okay, girls, in a cone, there's two heights, right? Yeah. So this one straight up height from the middle of the circle at the bottom, straight up to the tip, the point, right? That there is called the perpendicular height. Perpendicular height. And we don't like writing all them words, so we just call that H, right? There's also the length of this line here, right? And that's called the slant height. And we call that L. So everywhere, so the L is the distance from here to here. It's the slant height, as in it's the measure of the slanty line. Okay, is that right? Okay, so in there, girls, right, you can make a little right angle triangle for yourself. If you take a slice of the cone, you get a little right angle triangle in there, wouldn't you? Right, so this is a right angle triangle. This is H, this is L, and this is the radius. Would you agree? Right, so this is the radius of the bottom. Okay, so this is H, this is L, this is R. Okay?
Why is this straight line L?
Oh, sorry, because it should be the other way around, and that was a test and only you passed. So that's H and that's L. Right, okay, well spotted. Right, so H and L and R, right? Is that okay? Does anyone know what theorem can I apply to a right angle triangle? Pythagoras' theorem. So what would Pythagoras' theorem equal to? L squared would be equal to what? H squared plus R squared. Okay? So sometimes they'll give you one or two, right? So sometimes they'll give you two of these measurements and you'll be able to find the third using Pythagoras' theorem. So the hypotenuse squared, which is L, the long side, L squared is equal to the sum of the other two sides squared. Do you remember Pythagoras' theorem? No, we'll revise it in a minute, right? We'll do a few examples in a minute. Is that alright? Okay, so then yesterday we had the volume of the cone. So the formula is 1/3 pi R squared H. So to get the volume of the cone, girls, you need the radius and you need the perpendicular height, the straight up height. Okay? Now the curved surface area of the cone right, so the curved surface area, girls, does not include the circle at the bottom. Okay? So the curved circle area is just the bit that wraps around to make the pointy, right? So it does not include the circle at the bottom. So if you were asked for the total surface area, you'll have to add the excuse me, the circle at the bottom. Okay? So the curved surface area, girls, is pi r L. What does the L stand for? The slant height. Okay? So that's why I have to talk about the slant height, because the L comes into the curved surface area formula, whereas H is in the volume formula. Okay? No, there's no height in the curved surface area formula. It's just the L, the slant height. Okay? Are you alright there on the phone? Maybe it's the plug that's not working. Do you want to try a different plug? There's one there by Zainab. No? It's the charger, so that's not working, because there's definitely one of the plugs working. Right, are we okay with that? Have you that written into your notes? Right, okay, so what I'm going to do is an example is question 3 from last night. So example 1. Okay, here's a cone. Right, okay, so the radius is 5 centimeters. Now they give me the slant height is 13 centimeters, right? Okay, so they've given me R, and what letter do I call the slant height? L. So they've given me R and L. So part 1 asked me for the curved surface area. So the curved surface area is pi R L, and we'll say give your answers in terms of pi. So that's pi multiplied by 5 multiplied by 13, which is 65 pi and cm squared, because it's area. Is that okay? The total surface area is next. So the total surface area, remember the curved surface area doesn't take into account the circle at the bottom. So the total surface area is equal to the curved surface area plus the circle at the bottom, isn't it? And remember, girls, they give the curved surface area in the log tables. They don't give the total surface area, so you need to be able to spot that I have to add in a circle there as well. So that would be pi RL for the curved surface area, plus the area of a circle is pi r squared. Okay? Pi RL I just done, but I'll just fill it out again. So it's 5 by 13. Add pi multiplied by the radius to be squared is 5 squared. So into the calculator with that, okay, and press equals, and you'll end up with 90 pi centimeters squared. Go. Where did I get the which squared? 5 squared. Do you know the circle? So the curved surface area is just this bit, right? Okay, and there's a circle at the bottom for the total surface area. So I have to add in the circle at the bottom. So the formula to get the area of a circle is pi r squared. So I have to add in that circle at the bottom, pi r squared, and that's pi multiplied by 5 to be squared because the radius is 5. Sorry? This is two separate formulas, so I have to do them separately and add my answers. Okay, so I have to do the curved surface area up top and the circle then separate and add the answers. Okay, are we okay? Any more questions for me? Make sure and ask the questions now, because it's really good that someone asks questions, because it means A, you're listening, and B, if you don't get something, you have to ask. Now, the next one asks me for the height of the, so find the height of the cone, the straight up height. Okay, so this is where I have to draw my little right angle triangle. So if you imagine in your cone, right, you can slice a right angle triangle in there, can't you? So if you draw a right angle triangle in there, across the bottom is 5, the radius. The slant height is the slopey bit, okay? And this is the perpendicular height. This is the bit I'm missing, right? So this is the bit I need to calculate. So Pythagoras' theorem said the square and the hypotenuse is equal to the sum of the squares of the other two sides. First off, which line is the hypotenuse? The 13. It's always straight across from the right angle. It's always the longest side. So two things about the hypotenuse. It's straight across from the right angle, and it's always the longest side. Yes.
Is there log
Sorry?
Is there log
Yes. Except it goes h squared equals a squared plus b squared. But yeah. Right, but it's the hypotenuse, which is 13 squared, is equal to the other two sides squared. So square this one, what would that be? H squared plus 5 squared. Okay? Now, this h here, girls, it confuses people, because when we did Pythagoras' theorem, we probably called the hypotenuse h. But in this case, h is the straight up height, right? The perpendicular height. So it's the straight up height. Okay? So please don't get that mixed up and think that h stands for hypotenuse, because it doesn't. It stands for the straight up height. Okay? Does that make sense to everyone? Right? Okay? Because, and why am I calling it h? Why am I confusing you? Because h is in the formula, okay, for the volume. So I want you to know that that's what the h refers to. Okay? So it's the straight up height is h, not the hypotenuse. So into the calculator you do 13 squared, you get 169. Over this side you get h squared, and 5 squared, girls, is 25. Now, you put the letters at one side, the numbers at the other. Now, it's a good idea to put the letters over at this side and put the, normally we have it the other way around. But the reason it's a good idea is because I don't want to end up with a minus and have to change.
Excuse me, please, would Sarah Conlon go to Miss Garry's office now, please? Sarah Conlon.
So the 169 is on this side already. I'm bringing the 25 over, it becomes a minus 25. So I get h squared equals 144. So what square to give me 144, girls? 12. If you didn't know, what button would you press the calculator? Square root. So you go square root of 144. So that means the straight up height there is 12, and that's in centimetres because everything else is in centimetres. Is that okay? And then part 4 of that last night said, find the volume of the cone. So the volume of a cone is 1/3 pi r squared h. So that means it's 1/3 multiplied by pi, multiplied by the radius of the cone, which is 5 squared, multiplied by the perpendicular height, which is what you just calculated, which is 12. Okay? So all you do is type all that into your calculator, and they say give your answer in terms of pi, so that just means don't press S to D. Right? 5 squared by 4 is 100 pi, I'd say. And it's volume, so it's cm cubed. Okay? Is that right? Yes. Yeah. Right, so what we might do is, I might do some of the harder questions and then give you some of the harder questions to do. Is that okay? Yeah. So I'll do a couple and then you do a couple, okay? Can I rub this off? So I'm doing example 2, and I'm going to say, I'm going to do page 505. So example 2, page 505, question 6. Okay? So if you just, now I know you don't have your book, so I'm going to put it up here. Right? Okay? So 505, question 6. So I'm going to do it out first. We're just going to read it, and then I'll copy the diagram onto my thing. A cone is attached to a hemisphere. So you have a cone on top and a hemisphere on the bottom. Right? As shown, the total height of the object is 10 centimetres. Now, girls, I don't need the total height of the object. I need to do the cone separately, and I need to do the hemisphere separately. Right? I'm going to talk about that in a minute. Right? So it says, find the height of the cone, find the volume of the object. Okay, so here we go. So here's my cone on top of my hemisphere. Right, and it tells me the radius down here is 4. So remember that radius is the radius of the cone and it's the radius of the hemisphere, agreed? Now, they've told me the whole height of the object. Now, but I need to do them out separately, so I need to get the volume of the cone, the volume of the hemisphere, add my answer. So that means I need the straight up height of the cone. Right, anyone know what it is? So I only need from there up to the top. And if I draw this in, what would that also be, please? What would that be? That's also a radius, isn't it? Because remember, the radius goes from the centre to the edge, right? So it can go any direction. So if the radius going this way is 4, what's the radius going that way? 4. So what's the height of the cone? 6. Right? Okay? So to get the volume of that shape, girls, I need to get the volume of the cone, which I know has a radius of 4, and I've just figured out has a straight up height of 6. And then I need to add that to the volume of the hemisphere down at the bottom, and I only need one reading for a hemisphere, and that's the radius, which is 4 centimetres. So off I go to my log tables, and I get the formula for the volume. For volume of a cone, it's 1/3 pi r squared h. Yeah, sorry, do you know what? It's magnified because I was still reading the book. Right? So it's 1/3 pi r squared h. Right. They don't have a hemisphere, right, in the log tables, but they have a sphere. And a sphere is 4/3 pi r cubed. So what's a hemisphere? 2/3 pi r cubed. Or you can do 4/3 pi r cubed and divide your answer by 2. Okay, whatever you want. Okay, so fill in, it's 4/3 multiplied by pi, multiplied by 4 to be squared, multiplied by 6. Then that will be the cone add 2/3 multiplied by pi multiplied by 4 to be cubed. And in the question they said give your answer to one decimal place, so you just type it as you see it into the calculator. So it's 1/3 multiplied by pi multiplied by
Excuse me
4
please, just a
squared.
reminder, the Christmas art competition for all year groups, closing date for entries is December the 11th. All details on the school app or from the art room. Also last week, Read One launched their Christmas food appeal. They would be very grateful if you could assist them with this and bring in any non-perishable foods or toiletries. Every bit counts. And the collection box is just outside the chapel. Thank you.
Right, and when you press equals, it'll give you the answer in terms of pi, s to d it, right, okay, and when you do that, the volume is 234.57, so 234.57 ... is a bbig long decimal, but in the book they tell me to round it up to one decimal place, so what would that be to one decimal place, please? Yeah, 0.6. So it's 234.6 and it's volume and it's in centimeters cubed. Okay, is that right? Yes.
When I was doing it, like I did the volume of the cone first and then the volume of the hemisphere, but I got 234.7.
You rounded up too soon. Did you round these?
I rounded up the cone and the hemisphere first.
Yeah, no, what you should do is you should go to at least 2 places of decimals on these and then round at the end, okay? That's a lesson for everyone, right? You know, when it says round to 1 place of decimals, your answer, don't round until the very end. Don't round halfway down, okay? Because you'll have rounded too soon. Now, you'll only lose 1 mark for that, okay? Right, I know it's 1 mark, but marks are hard to come by, so let's hang on to the ones we get, yeah? Okay, right, are we okay with that question? Right, okay. I'm going to do number 11 next, okay, and then I'll talk you through some and leave you off, okay? Right, so what example am I on now? Example 3? 3. Sorry, I rubbed that off really fast. Did I do a bad thing? Yeah. Page 506, question 11. So again, I'll bring you over in 1 sec. I'm going to draw the diagram first.
The answer for example 2.
Yeah.
Was that in centimeters cubed?
Centimeters cubed. Its volume is centimeters cubed. Remember, volume is 3-dimensional, so it's cm3. Area is 2-dimensional, so it's cm2. Right. Okay. I'll put this up now and read it for you all. We'll read it together, okay? Yeah, they're after dropping. Right, before we had them dropping a ball in. Right, now they're dropping a cone in. Right. Sorry? The radius is 8. I'll put that back in a minute. Now we'll just read it first, okay? Okay, so so here we have a right circular cone, right, of radius 6. So there's a cone in there. It's got a radius of 6 and a height 12. So when they say height, girls, they mean the straight up height, the perpendicular height, H, not L, right? Is immersed in a cylinder partly filled with water. So you drop the cone in, what happens to the water level when you drop the cone in? It rises. And look, it makes a little mini cylinder there. So how much it rises is a little mini cylinder. Would you agree? Right? So basically the volume you put in is equal to the volume that it rose. So the volume of the cone that you put in is equal to the volume of this little mini cylinder. Would you agree? Right? Okay. So it says find H, right? So the water went up and it made a little mini cone, or a little mini cylinder. So the water went up, so the volume of that is equal to the volume of the cone you put in. So the volume of that cylinder is equal to the volume of the cone. Yes. 8 centimeters is the radius of the cylinder, yeah. Bad drawing, you can tell from their drawing. My art wouldn't be great. Sorry? Oh yeah, I'm still magnified, sorry. Okay, so the little cylinder that went up, the rise made a little cylinder, right? So the volume that it went up is equal to the volume of the cone, okay? Right? So volume of the cylinder, off you go to your log tables and you get pi r squared h, right? And then you go and you look up the formula for the volume of a cone, which is 1/3 pi r squared h. Now what's the story? The r here and the r here, are they the same r's? No, they're not. This is the radius of the, which is 8. This is the radius of the, which is 6. And this height is the height of the cylinder, isn't it? And this, which we're looking for, and this height is the height of the cone. Now the cone is turned sideways, right? Okay, so if you want to just turn it back that way, you're used to, it's the way you're used to it, isn't it? Right, okay. So are the pies the same? Yeah, so what can I do with the pies? Knock them off, okay? So I go r squared, so this is the cylinder, so 8 squared, multiplied by the height of my new cylinder, I haven't a clue what it is. That's what I'm looking for. Equals 1/3 multiplied by the radius of the cone, which is 6 squared, multiplied by 12, okay? 8 squared by h, 8 squared is 64 by h is just 64h. Over this side into the calculator with that, and you get 144, no, 144. What I do now? Divide by 64, won't I? So it's 144 divided by 64, and we'll say that goes how many times? 2.25. I would have never got that in my head anyway. 2.25, and everything's in centimeters, so this is 2.5 centimeters. So the water jumped up by 2.25 centimeters. Is that okay? Is that right? Right. What I'll do now is we'll look at a few of the other ones, right, and we'll talk about them, and then I'll leave you off to do them. Right? Is that okay? So we'll talk about them first, just to put us on the right track. Okay? So the first one I'm going to ask you about is number 7. So we're going to look at number 7 in a minute. Okay? Is it big enough? Can you read it? Number 7, can you read it? Right, okay. So here we have a cylinder and a cone on top of it. Now, so separate them out. Okay, so we'll have the height of the cylinder and the height of the cone, won't we? Right, they're on their sides. We're used to them being up the other way. So flip them up the other way. They have the same radius, don't they? So how to get the volume of the cylinder in terms of pi, find the volume of the cone in terms of pi. Just fill in the cylinder formula, fill in the cone formula, and add your answer. And it said correct to the nearest whole number, so that means S to D it and round it up to the nearest whole number. That's not too bad, sure it's not? Right, okay. Number 8, let's look at number 8. There's no picture. Right, okay, right. But for number 8, they said a solid metal cylinder. Right, okay, so we had a cylinder. It's got a radius of 5 and it's got a height of 12. I'll put this up now in a minute. So there's my cylinder. Radius of 5, height of 12. Right, it's melted down. Right, so they melted it down and they turned it into a cone. Right, so they turned it into a cone. So if they used all the metal, what can I say about they have the same volume, don't they? So they have the same volume. If they used all the metal in the cylinder to make a cone, they have the same volume. So we're now recast into a cone of base radius 10, and we're missing the height. Right? They haven't told us what height the cone is. But we do know they have the same volume, don't we? So off you go. Pi r squared h is your formula for a cylinder. 1/3 pi r squared h is your formula for a cone. You know they're equal. Can I knock off the, what can I do? Knock off the pi's. Can I knock off the r squares? No, why? Because this is the radius of the cylinder, which is 5. And what's this radius? The radius of the cone, which is 10. Height, you know, right, it's 12. Height over here is what you're looking for. I'm going to leave that one, the rest of it with you. Okay, is that right? So that's 7, 8, right? Yeah, go on. Right, go on, have not long, 3 minutes, okay? Right? That's not very long, is it? 4 minutes, so. I'm just checking the time on this. 15:06, be back at 15:10. And if you're late, I'll never give me a break again. Right, okay, ready to go again? Right, okay, so what I'm going to do is leave you off there to do number 7 and 8, right, and then I'll correct them, right? Is it okay if I don't put them up in Teams and just leave them up there? I've no phone today. I feel like my right arm is severed. Right, so you do number 7 and 8, right, and then I'll correct. Say that again. Page number 505. Girls, we shouldn't have to talk about it now. Come on, let's just do it. Shauna, will you sit down and do some maths, please? Oh, sorry, that's not helpful.
What does it mean that it was recast into the code? Like, oh, we dropped into it.
Where is it? 8. A solid metal was recast. It was remolded. It was like, imagine it's like a candle, and they melted it down, collected all the wax, and then made it into a cone, right? All you need to know when it's recast, all you need to know is the volume you started with is the same as the volume you finished with. Okay, so the volume of the cylinder is equal to the volume of the cone. Yeah, if it's pi, you S to D it and then round it up to the nearest whole number.
Okay.
Will I flash up the answers there for you just to make sure you're going okay? Right, so for number 7, sorry. Right, number 7, the volume of the cylinder is 54 pi, the volume of the cone 12 pi, and when you add them together and round it up to the nearest whole number is 207. Right, and for anyone who's number 8 done, the answer is 9 centimetres, but if you haven't, to ignore the answer. Yeah. Pi, yeah, and then S to D it and round it up to the nearest whole number. The final answer 207. When you round it up to the nearest whole number, 207 was the answer to question 7. Right. How are we going? You're still working. Okay, I'll do them in a minute if you're stuck.
What was that question?
9 centimetres. Did you get it? Good.
I got like 980 there, like.
I calculate the height, it doesn't work out evenly. Hang on a minute. Pi r squared h, so that's 25 by 12 is 300.
And I got 33.3.
Cone. So it's, sorry, so you get pi r squared h equals 1/3 pi r squared h. The pi's will go, and you go r squared by h, which is 5 squared by 12, which is 300, right, equals 1/3 by 100 times h. Yeah, it's fine. Yeah, if you go down the decimal route, it won't work out perfectly, but if you stuck with the fractions, so instead of putting in 0.33 or whatever it was, there you put in 1/3. Yeah, there you.
So that's still okay?
It's still perfect. Yeah, it's still great. Yeah. Right, are we done?
Yeah.
Right, does anyone need me to do any bit of number 7? Or any bit of number 8? Yeah, do number 8. So, right, no bother. So, basically they're saying, sorry, and reduce. So they're saying, right, that they started with a cylinder and they melted it down and they used all the metal to make a cone. So that means the volume of metal, that was in this pi r squared h, was equal to the volume of this, which is 1/3 pi r squared h. Right. Now, the pi's are the same because pi is just a number. The r's and the h's are not, because this is the radius and the height of the cylinder. This is the radius and the height of the cone. So r squared, so the measurements for the cylinder is 5 squared and the height is 12. Right, over this side I have 1/3 multiplied by the radius of the cone, they told me was 10 squared, multiplied by h, the height of the cone. That's what I'm looking for. Okay, into the calculator that you get 300. Right, over here you can do 1/3 by 10 squared. Now if you turn it into a decimal, girls, you'll be slightly off, but you'll still get full marks. Okay, but I'm just going to leave it as a fraction. It's at 100 over 3 h. Is that alright? So when you do 1/3 multiplied by 10 squared, you'll get a fraction. So then what's stuck to the h? 100 over 3. So over here it's 300 divided by 100 over 3, which will end up being 9 centimeters. Now if you went the decimal route, you get 9.09 or something like that. That's perfect. Okay, that's absolutely perfect. Okay, right, but fractions are actually more accurate though than decimals, because you know recurrent decimals go on forever and you can't be typing in numbers forever. So fractions are always more accurate, but it really doesn't matter if you got 9.09 or 9.0 whatever, it's still the same answer. Is that right? Okay, right, are we good with 7 and 8?
Yeah.
Right, okay. Now number 9 and number 10 are quite similar, right? Okay, so for number 9, we'll just read it for the moment and I'll give you your homework then, right? Number 9, a cone and a sphere, and they both have the same radius, right? And the volume of the cone is equal to the volume of the sphere. So you start off, the cone equals the sphere, right? Okay, knock off the pi's, multiply in what you can and do your algebra manipulation to see what's left. Okay, that should be okay for you, right? This one, a cone and a radius, a cone and a cylinder have the same radius or same volume. Let one equal the other and just fill in what you can and multiply out and see what happens. Okay, there 9 and 10 are very similar to 8, which is what we've just done, right? Okay, turning over onto the next page. Right, okay, the volume of a cone, number 12 there, I've done number 11. So they're telling me the answer. 1/3 pi r squared h equals that. The cone's height and radius length are equal. Right, okay, will I do that one for you? Right, okay. So we're just looking at number 12. So they're telling me the volume of a cone is, what's it? Where am I? 512 pi over 3. Okay, is that right? Okay, and then they tell me the radius and the height are the same. So I know the formula for the cone is 1/3 pi r squared h, right, equals 512 over 3 pi. They're telling me the answer. What I do now? What do you see at each side? A pi, so knock off the pi at each side. Right? Okay. Now what they're telling me is the radius and the height are the same. Right? So they told me the radius and the height measured the same. So instead of that height, what could I put in? A radius, couldn't I? Okay, because the height and the radius are the same. So 1/3 multiplied by r squared multiplied by, instead of height, I'm writing radius, equals 512 over 3. Is that okay? Right, what's r squared by r, please? R cubed. Right, by 1/3 is just over 3. Equals 512 over 3. They're both over 3, so you can knock off the over 3's. So you get r cubed is equal to 512. How will I find out what number by itself 3 times will give me 512? What's the answer? Or what's the button you press in the calculator? It's the cubed root. So it's shift and square root 8, is it? Thank you. So r is equal to 8 centimetres. Yeah, they were both over 3, so I knocked off the 3's because it's there at each side. Yeah, because when you multiply by third, multiplying by 1/3 is the same as dividing by 3. So like if you do 1/3 multiplied by 12, that's the same as 12 over 3. Okay? So multiplying by 1/3 is the same as dividing by 3. Yes?
If it was 2/3 by r squared, would you do
2/3 by
r squared?
r squared. Yeah, you could just do 2r squared on top and 3 on the bottom. Okay? Right? Okay, are we all alright? Okay, that was number 12. So I'm going to leave you number 13 to figure out all by yourself. And I'm going to leave you number 14 to figure out all by yourself. And number 15. So I want you to do 9 and 10 on the previous page. And 13, 14 and 15. Okay, and I'll put up 9 and 10 and then I'll start taking pictures, okay? So, it's on page 505 to 506. Okay, so it's pictures and you're page 505. So I'll put it up in Teams now, it just takes me ages with that thing. So we're doing 9, 10, 13, 14 and 15. Okay? So I'll go back to 9 and 10, blow it up, and you can get started on 9 and 10, right? And I'll be sticking up pictures then. Okay. Sorry? Yeah, I will. Yeah? Right? Okay, and you can get started on 9 and 10 and I'll put the whole lot up in Teams now. Yeah.